Hey everybody, welcome to video number 5 for business, math, and calculators. In this video, we're going to look at adding and subtracting fractions. So with that, I'm going to go ahead and share my screen and we'll get started with a few sample problems. All right, so adding and subtracting fractions. The first problem we'll look at is just a basic addition problem. So with that, what we want to do is we want to find the sum. So again, remember from before, we know that the word sum means addition. So we're going to add 2/5 and 1/3. And basically, when it comes time to solve an addition problem involving fractions, is you have to have a common denominator. That's probably the biggest rule that you got to remember. You got to have a common denominator. So what we need to do is we need to figure out what 5 and 3 can both divide into nicely. In this case, 5 and 3 can both go into 15. So 15 is going to be our common denominator. Now, we have to make sure that our fractions are rewritten in equivalent form. And in the previous video, we talked about what it means for fractions to be equivalent. So what we're doing here is we're essentially expanding these fractions to have the new denominator of 15. So what we do is once we figure out what that common denominator is, we have to adjust the numerators accordingly. So for the first fraction, because we have to take 5 times 3 to get 15, we're going to take the 2 in the original fraction and multiply that one by 3 as well. Again, we multiply the top and the bottom by the same thing in order to keep the new fraction equivalent to the original. So we end up with 6/15. So 2/5 is equivalent to 6/15. We do the same thing with the second fraction. In this case, 3 times 5 gets you 15. So we're going to take and multiply the 1 times 5. So 5/15 is equivalent to the original 1/3. Now that I've got common denominators and now that I've rewritten the fractions in equivalent forms, now I can go ahead and do the addition pretty easily. Okay, what you want to do now is you want to go ahead and just add the numerators like you would any other number. So 6 plus 5 is going to get us 11. And then the key thing here is you keep the denominator the same. So you don't add them together, you just keep them the same because essentially you're taking 6 pieces and 5 pieces to get the total of 11 pieces. And each piece is a 15th of the total amount. So we keep the denominator the same, so we end up with 11/15. Now, as a final step, you should always look to see if you could possibly reduce, and depending on the problem, sometimes you can, sometimes you can't. In this case, there really isn't anything that divides into 11 and into 15 evenly. So with that, we know that 11/15 is our final answer. And there you go. We've just added 2 fractions together by finding that common denominator and then going through the process of adding the numerators, keeping the denominator the same, and then, like I said, checking to reduce at the end if possible. So with that, let's look at a second example. This time, let's look at a problem that involves mixed numbers. And this type of problem is probably the most complicated type of addition problem involving fractions. Okay, so I'm going through an example that involves pretty much all of the steps that you need to go through when it comes to adding mixed numbers. Now, like we did before, the first thing you want to do is you want to find a common denominator. So we're going to focus just on the fractions 1/2 and 5/7. And 2 and 7 can both go into 14. So what we're going to do is rewrite our fractions with 14 as the denominator. We then adjust the numerators accordingly, just like what we did before. So in that first mixed number for the 1/2, 2 times 7 is 14. So 1 times 7 gets you 7. So 1/2 is the same as 7/14. And then we do the same thing for the second fraction. 7 times 2 is 14. So 5 times 2 gets us 10. So 10/14 is equivalent to the original 5/7. Now, here we just focused on the fraction portions of the mixed numbers. The whole number pieces just kind of tag along. So we're not really changing those or messing with those at all. Now what we're going to do is we're going to go ahead and add up the fractions. So we add the numerators. So 7 and 10 gets us 17. We keep the denominator the same, so that stays as 14. Then we go ahead and just add up the mixed numbers. So 5 is the result from 3 plus 2. So now we've got a mixed number, 5 and 17/14. Now this is where this problem is a little bit tricky, is when you write a mixed number, you technically don't want to have an improper fraction within the mixed number. You want to try and reduce this thing down. So we're going to take the 17/14 and simplify that out. 14 can go into 17 one whole time with 3 left over. So we take that 1 and we add it to the 5 to get 6. And then the 3 left over is the 3/14. Okay, so we had to kind of reduce this fraction a little bit by converting the mixed number into an improper fraction and then adding that improper fraction to the 5 that was already there. So when all said and done, our final answer is 6 3/14. And again, this is probably the most difficult type of addition of fractions problem because it involves all of the steps in our process, including that step of having to reduce and write the final mixed number as a correct mixed number. All right, now our next problem involves subtraction, and basically the only difference between a subtraction problem and an addition problem when you're dealing with fractions is we are subtracting rather than adding. So we're going to find the difference this time. Difference means subtract. So we're going to take 2/5 and we're going to subtract off 1/3. So again, I have to have a common denominator. 5 and 3 both go into 15. All right, 5 times 3 gets us the 15. So 2 times 3 is going to get us 6 for the numerator. On the second fraction, 3 times 5 equals 15. So 1 times 5 equals 5. So again, we rewrite our fractions in equivalent forms with that same common denominator. This time though, the only difference is when we go to put the fractions together, we got to subtract the numerators. So 6 minus 5 gets us 1 in the numerator. So I had 6 pieces and I'm taking away 5 of them. So that's where the 1 comes from. The denominator stays the same since that's the size of the pieces that we're combining together. And then the last step, as always, is check to see if you can reduce. And you may, again, or may not be able to reduce. So in this situation, nothing can go into 1 and into 15 evenly. So 1/15 is our final answer. And there we go. All right, let's do one final problem, this time subtracting mixed numbers. Okay, so we're going to take 3½ and subtract 2 5/7. So like we did before, we got to have a common denominator for our fractions. 2 and 7 both go into 14. Adjust the numerators accordingly. So 2 times 7 is 14. So 1 times 7 is 7. On the second one, second fraction, 7 times 2 is 14. So 5 times 2 is 10. And then the mixed number pieces just kind of tag along. Okay, so we're not changing those at all. We're just focusing on changing the fractions and writing those in equivalent form. Now, here's the trick on this problem. And again, this is what makes this subtraction problem a little bit trickier, is the next step is going to be to subtract. Okay. However, I can't take 10/14 away from 7/14. I can't take 10 away from 7. So what I have to do is I have to borrow. Okay. Now, here's how borrowing works when you're dealing with a fraction. What you're going to do is we're going to borrow from the 3, and that's going to become the 2 that you see there on the screen. But what happens is because my fraction is cut into 14ths, there's 14 pieces, what I have to do is whatever the denominator is, I have to add that amount to the numerator. Okay, so essentially what I'm doing is I'm taking 7/14 and I'm adding 14/14. Okay, 7 plus 14 is 21, and we keep the denominator the same. So that's where that comes from. So again, the thing to remember is whatever the denominator is when you borrow, That's what you add to the numerator to get the new fraction. Okay. And again, we borrowed the 1 from the 3, so that's why it was knocked down to a 2. We only do the borrowing on the top fraction, so the bottom fraction is going to remain unchanged. Now I can go ahead and I can subtract my fractions. Okay, 21 minus 10, I can do that. That gets me 11. Okay. I keep the denominator the same, so that's the 14. And then I go ahead and I subtract my whole numbers. Now in this case, 2 minus 2 gets me 0 for a whole number. Okay, so this is a situation where the whole numbers happen to disappear. A lot of times that doesn't happen. A lot of times you'll still have a whole number portion to your answer. It just kind of depends on the nature of the fractions that you're combining together. Always check to see if you can reduce if possible. So 11/14, not much goes into 11 and into 14. So our final answer is simply 11/14. All right, so those were a couple of quick examples of adding and subtracting fractions, as well as adding and subtracting mixed numbers. Like I said, I tried to go through on the mixed number side of things, problems that are the most complicated that you'll see. So hopefully the examples were helpful. If you do have any questions, again, don't ever hesitate to reach out and let me know what I can do to help you with these. But again, I hope the examples help to illustrate the process when it comes to adding and subtracting fractions. Thanks for watching the video, and we will see you in the next video.